When wind turbine yaw gears fail, operators face a costly choice: hire a crane for a complete replacement or attempt a risky repair. This week we speak with Søren Kellenberger, sales director and partner at CNC Onsite. CNC Onsite brings precision machining Uptower, making yaw gear repairs faster and more reliable without using an expensive crane.
Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Søren, welcome to the show.
Thank you very much, Alan, and thank you for inviting me.
Well, we want to understand first, what is causing yaw gear teeth to be damaged in some of these turbines? Because the photos I have seen are remarkable. The teeth are just gone. How does that happen?
I think there can be a number of reasons, and it depends a little bit, I think, on the turbine, how the yaw ring was designed, and stuff like that. But if you look at some of the older turbines, the yaw ring wasn't hardened, so there, in many cases, you'll just see wear and tear from years of use operation. And typically, in a wind farm, you have a dominating wind direction, right? So especially in Denmark, it's mainly blowing from the west. So all our wind turbines are pointing that direction most of the time, which means that they are yawing within a limited area of the yaw ring. So a limited area is taking the majority of the wear cycles. So therefore, you see some local wear and tear, and finally they will be worn down razor sharp, basically, and break off eventually. So that can be just one cause of the failure. We also see sometimes that even though they are hardened, they of course don't wear that much, but they will more break off, and probably due to some extreme loading. And I guess that can be caused by either some misaligned yaw gear. It can be extreme loads. You have some sites where you have really wind directions changing very fast that is causing unforeseen loads on the turbine. So you have actual extreme loads that are higher than the design loads. You could probably also sometimes see foreign objects that are falling into the yaw ring and being squeezed between yaw ring and yaw gear, causing some damages. So there are a number of different reasons for these damages, I guess.
Do you see anything environmental? Like in my mind, I think of these Arctic turbines, right? The ones that are operating in the extreme cold. When metal gets cold, it gets brittle. Do you see more yaw teeth get damaged in those territories as others, or is it just kind of across the board the same?
No, we haven't seen that these cold condition turbines are affected more than others, but we do see that the weather conditions play a significant role, and if you have maybe yaw ring damages on 2 to 5% of your turbine fleet, then they will not be evenly distributed across your different parks. It tends to be that if you have an affected park due to some special weather conditions in that area, you seem to have a lot of problems in that one park, and you can have other parks that will run perfectly fine for the entire lifetime without any issues on the yaw ring.
Well, at least these inspections aren't super difficult.
Yeah, it's pretty obvious when they are missing.
What's the effect when they're missing teeth like that? Is the turbine just not able to yaw anymore, or is it really at risk of some structural overloading when that happens?
Yeah, I mean, in the beginning, I guess you won't be able to yaw, or at least it will be less accurate. If you have wear, it will start being less accurate, and that will of course cause some lost production. Potentially, if you are misaligned on your yaw system, you are also introducing unwanted loads to your turbine. So I guess it could have also other consequences when you are other than just lost production when you have a yaw misalignment. Um, but yeah, in the end, you won't be able to yaw the turbine if you have too many damaged teeth.
So does the turbine send out an alarm when that happens? Is it just a complete shutdown? The turbine just says, no more, I can't move, and I stop? Or it doesn't recognize that this is even a failure?
To be honest, Alan, I'm not 100% sure, and I think it depends also on the turbine, um, how new or old they are, and how advanced their control systems and condition monitoring systems are. Um, some of them, they just have on/off on the yaw gears, and they won't recognize that one yaw gear is just spinning in free air. But you can have others that have more advanced control systems where you can see that some of the yaw gears are suddenly using a lot more power to yaw the turbine, which will indicate you have some kind of yaw issue. If it's a broken yaw gear, or if it's some teeth missing in that area where that yaw gear is placed, you can't probably tell, but there are different warning systems possibilities. But again, depending on how old or how advanced your turbine is.
Wow. So this is really serious. It's just beyond just the tooth missing. The consequences for the turbine can be quite dramatic. Now, CNC Onsite obviously is all about doing machining on the turbine at the facility, which is remarkable. How do you go about fixing this problem?
Basically, we have a smaller CNC controlled 3-axis CNC controlled machine that we bring up tower, and these machines are adapted to the different turbine types. As you can imagine, the turbines were not designed for these kind of repairs, so the design engineers originally didn't leave much space for a machine in those areas. But so we customize the machines to fit the different turbine platforms, and yeah, basically we use the internal crane of the turbine to hoist the machine components to the turbine. Use the internal crane to position it at the yaw ring, and then we mount the machine on the yaw ring itself, which also gives us the advantage that even if the turbine is moving a little bit due to wind, we are moving along with it, so it doesn't influence our accuracy when machining.
That's quite impressive. Because the alternative is, and what I've seen is, you lift the hole, you take the blade set off, and then you lift the hole in the cell off, and then you go in, you try to replace the yaw gear, which is super expensive.
That is very, very expensive. Yeah.
So you're really talking about taking up some precise machining equipment up tower. Doesn't really matter if the wind's blowing or not. You're fine. You're all inside, and you're going in and machining what remains of those teeth. I want to have a sort of a dentist equivalent of this. So it's like you have a broken tooth, and the dentist comes in and goes, okay, we're going to grind that tooth off, and we're going to smooth out, and we're going to put a replacement on top of it, like a crown, right? It's basically a crown. So that process takes how long to do once you kind of up tower and you're starting the machining process?
If we use like the Vestas V90 3 megawatt platform as a sort of baseline, then it takes we have our teeth segments, our crowns, if you want, in segments of 6 teeth, and it takes roughly 1 day to once we are up and ready to replace 6 teeth. So for a replacement, you need to consider 1 day of hoisting and getting in place, and then 1 day for each segment you need to install, and then 1 day to pack up and clean and get back down. So we get quite a fair bit done in a week.
Yeah, that's impressive. So there's a couple of activities here that have to be done, right? Of course, you're getting up there, you mount the CNC equipment. That's one big part of it. But then you're milling up tower, so you have to deal with. You guys have a system deal with all the filings and tailings and catching all that stuff. And then once you put the new teeth or the new teeth get in place, are they welded in place, or how are you attaching that?
No, we bolt them in place. So because we have a CNC machine, we can do a very accurate milling process up there. So basically, we as you say, we remove the remains of the old teeth, and we machine like a pocket in the yaw ring, and that one is milled within a couple of hundreds of millimeters in tolerance. And then we have the benefit because we know the design of the yaw ring, so we bring prefabricated segments that have the exact same shape as the original yaw ring, and they are of course manufactured in a machine workshop. So they have very good tolerances as well. And then we basically create a press fit. So we either slightly pre-bend the segment to install it, or we freeze it. We have some small freezers we can bring uptower as well and cool the segment down to minus 80 degrees, which gives us just enough space to easily fit it. And then as it heats up, it's a press fit, and then we keep it in place with bolts as well.
Wow. I didn't realize it was a press fit. That's insane. That's better than the manufacturer delivered on site when the turbine was new.
Yeah, it could be.
The other way I've seen this repaired, if you watch LinkedIn enough, and Joel and I are constant viewers of crazy LinkedIn wind turbine repair videos, and Instagram, there's a lot of this, and Facebook too. When they have broken teeth, you see guys up there with welders, and they're up in there and they're adding filler, trying to rebuild it, trying to reshape it. Then you see them grinding on this gear. What are the problems with doing that approach?
We do actually also work with some welding companies, but because you can have some situation where welding is your only opportunity. But we can get back to that. But the challenges with welding is, of course, you have a big, massive steel ring, so it absorbs the heat quite fast. So controlling the heat and the temperature in your welding process is difficult. The space is just as limited for welding, and they need to fit a person in there. So you also have the disadvantage of having like hot works in confined space, which is not so nice. And then finally being able to grind those teeth into the original shape is also relatively challenging. You don't have much space when you are in there, and you would want to try and get that contact surface quite straight to distribute the load from your yaw gear when you start operating again. And I think that is probably the most challenging part, where we have the benefit of machining, bringing a pre-machined segment that has that exact shape. I think that is probably one of the biggest benefits to our process. And because it's such a manual process of grinding, it can be difficult to get that shape, and that can give you some extra loads on a welded tooth, which can lead to damages again faster than what we see on segments.
There's one thing for rebuilding teeth on like an excavator by welding up a bunch of metal, and but teeth that need to be used in a basically a ring and pinion set, or a tooth gear thing. It's got to be exact. It has to, because if not, you're just going to be back up there in a year or two doing the same process, because it's just not going to last.
It's temporary. Does a yaw motor gear and all the machinery that's there, and the mechanisms that are there, does that need to be updated too, because it's been working against these gears that have been not the right shape for a long time? That in order to get this really fixed, you need to put the proper teeth in the yaw gear, but also on the motor, you need to take a look at it and make sure it's up to snuff.
Yeah, I think that is typically also a part of the inspection they do, that they check that all the motors and gear wheels there are okay. It's normally not a part of our process to do that. That would be the turbine owners or their own technicians who would check that upfront or right after we complete our work. But yes, I mean, when you are up there fixing it, I would definitely recommend that you check the remaining system, and potentially also try to look for the root cause. If you do have misaligned yaw gears or something like that, it could for sure be an advantage to get them aligned to avoid having the same damage again soon after the repair.
So, how many of these yaw teeth replacement are you doing in a year? Because my guess is it's quite a number from what I've seen out in the field.
You can say it's still a relatively new technology, even though we've been doing it for 5 years. It's still a conservative industry. They want to see new technology introduced and see how it operates and works. So it's not that we do a yaw ring every week, but we have installed more than 100 segments since we started, and we see that it is taking off. Now, the first segments have now been running for more than 5 years, and proven themselves very well. So we certainly do. And also, you see that the turbines, the number of turbines that are reaching that age where you could expect some wear or damages to your yaw ring is also increasing significantly. So we will be seeing more repairs over the coming years for sure.
I think that's a big part of the conversation here is, of looking in the European market. Like if you look at Spain right now, their fleet is starting to get to that close to end of life or life extension. What does it look like? Is it repower? Is it refurbish? How do we keep these things running? And Alan and I just had a conversation with a company here in the States that's doing a lot of repowers just the other day. And I was thinking about that there too, because in the States we have this, PTC driven repower thing where you could put a certain amount of value back into the turbines, still qualify for some subsidies. And I was thinking, man, with all these older turbines, what else can be done here? And some of that would be refurbish, fix these yaw gears, fix these kind of things to make sure that you're maintaining that level of performance that you want. Or, I mean, if you've been operating like this for a long time, you may be getting back to baseline. At a minimum, would be nice to get that out of it. So I think that the market for what you guys are doing is going to grow massively globally right now, right? We could see a lot of applications from here for in the States with our 75,000 and change turbines we have. Plus that European market that's changing. So are you guys starting to get some calls from, how is it more like damage during regular operation and this is what's happening? Or, hey, we're at getting close to end of life. Can you help us do an assessment on what this looks like? Are you getting those calls?
Both, yes. So most operators, I guess they start really looking for this when they see an issue. But if they have had turbines in other wind farms, for instance, or even some of them that have been damaged earlier in the lifetime, they are more aware of these issues, and they would also contact us for inspections and evaluations if what can be done and to get some budgetary quotes and stuff like that to see if there's a return on investment within their potential lifetime extension. So yes, we do get both. And I mean, we've been in Japan to fix teeth on a turbine. We've been across multiple countries in Europe. We've just sold a machine to New Zealand together with the first 25 segments. They will get together with this machine. So it is picking up around the world, and we also have several inquiries from the US. So I would be very surprised if we weren't doing some turbines in the US next year, also on the yaw ring side.
So, can an operator buy the machinery and do this process themselves with your direction, of course? Or is it always required that CNC Onsite people be there to do the process?
No, it's not a requirement that we operate the machine. It is very much a case by case discussion with our customers. If they have the technicians with the right skills, and they have the volume of turbines to keep them up to speed on using these machines. It can make sense that they buy a machine and we train them. Others prefer that we come and do an all-inclusive service. So it is basically up to the customer, and we discuss that case by case how we make the best project.
And what process is used if you're offshore on these massive 8, 10, 12, now 15 megawatt turbines? Is the process basically the same on those turbines?
It is completely the same process. Only difference is the transport there. That we have to go by CTV and not by car. So that is basically the only difference. If the turbine is onshore, offshore, doesn't make any difference for us. It is still the exact same milling process and installation process. We don't need any other external equipment.
How big is one of these kits? Like if you're going offshore, if you're transferring, I know like on offshore, on the transition piece, there'll be a little crane sometimes and stuff, but like weight and dimensions, what does it look like?
That depends on the turbine. As I mentioned before, though, most of these turbines weren't designed for this kind of repair. So we don't have a one fits all machine, and the segments are also different because the yaw ring in a 8, 10, 15 megawatt turbine is way bigger than in a 2 or 3 megawatt, of course. But if we take the 2, 3 megawatt size turbines, our machine is around 80 kilos, and the segment is weighing 8 to 10 kilos. So it's easily transferable. And we always make sure that we can, if the machine is too big or heavy when it's assembled, we always make sure that each component can be handled by the internal crane and go through the hatch in the nacelle, because that is very important also. And in terms of keeping the cost down, that you don't need any external cranes for this operation. But I think our heaviest machines for these large offshore turbines is around 200-300 kilograms. So when they are fully assembled.
So for me, if I'm an ISP in the States and I'm listening to this podcast, I'm thinking, ooh, new service line. I need to get a hold of Søren, so I can be the person that gets called in the States to do this.
And Søren, how do people get a hold of you? How do they reach out to CNC Onsite?
Either through our website, cnconsite.dk, where we have all our contact details listed, or directly to me at my email, ssk@cnconsite.dk, or call me. My phone number is also on the website, so there they are most welcome to reach out to us.
It's amazing technology, and it needs to be utilized across the world, because I've run into a number of operators with yaw gear problems, and they're stuck, and they didn't realize you existed. So hopefully this podcast gets to them and we can connect you up and get you busy, because there's a lot of yaw gear repairs that need to happen over the coming repair seasons. So Søren, thank you so much for being on the program. Joel and I have learned a ton.
Thank you very much for having me.